Jerry Neyman was a Polish statistician who later immigrated to the U.S. and spent his later career at Berkeley. He was one of the most influential statisticians of the mid-20th century. Among other things, developed theories of statistical inference, which remain major standards in the field today. But the article that we're interested in was published in 1934 in the Journal of the Royal Statistical Society, titled "On the Two Different Aspects of the Representative Method, the Method of Stratified Sampling and the Method of Purposive Selection." In this article, Neyman not only demonstrated the superiority of random selection over any purposive method, but he also showed how purposive selection could be subsumed by stratified sampling, and thus brought within the field, or the fold, of probability sampling. The idea of stratified sampling is simply that we might divide a population into groups. Those might be regions, for example, but then do probability sampling across those groups and within the groups. That stratified sampling allows a variable such as region to be an element of the sampling scheme, but still provides full probability sampling for the selection of individuals or units within the sample. And so Neyman, in this 1934 piece, showed how efforts to use things for purposive sampling, like region, both led to huge mistakes, and how by making them probabilistic through stratified sampling could provide the same information far more reliably. The motivating anecdote that Neyman uses throughout this article is the story of two Italian statisticians, Gini and Galvani, who attempted in the 1920s to construct a representative sample based on the Italian census of 1921. They chose 29 representative districts throughout Italy that they matched on a dozen different variables to census averages. So in that sense, these districts match the census on these 12 particular variables. But when they turned to other variables, they found this sample was, as they said, violently different from the census. So the matching on those dozen variables, even all 12 of them, didn't mean that their representative sample would also match other characteristics. So Gini and Galvani concluded that a sample could not represent all the attributes of a population simultaneously. But in his paper, Neyman demonstrated that random selection could in fact overcome these problems. Further, he showed that if one wanted to represent, say, regions in Italy, you could simply stratify the sample by region and take random selections across the strata, thus guaranteeing that regions were represented proportionately in your sample, while at the same time maintaining the probability basis of selection. This demonstration was so powerful and persuasive that it effectively ended arguments among statisticians, at least, in favor of purposive selection. In the U.S., developments in the late 20s and early 30s continued in sampling for social measurement. One of these areas was in the field of agricultural sampling and agricultural statistics. The Statistical Laboratory, founded in 1924 at Iowa State University in Ames, played one important role in developing probability sampling applied to geographic areas, and in particular to the problem of estimating crops and how much crop production would be done. In the 1930s, the Department of Agriculture asked the laboratory to develop better methods of estimating crop production. The traditional method that had been used at the time was a combination of questionnaires mailed to farmers, assessments from county agricultural agents, and some kinds of physical samples, for example, sending county agents out to particular places and walk out into a field and measure the corn, for example. In 1938 and 39, the statistical laboratory responded to the Agriculture Department's request by developing a random sample of 800 Iowa farms. This sample was based on probabilistic sampling of particular areas, counties, then sub-areas like townships of a county, and then areas within that until farms were located. This made the selection of farms based on probability the first example of what we now call area probability sampling. The results of this was to then go and conduct an interview with the farmer at these places, asking about the amount of crops they were planting, what they expected their harvest to be, and a variety of other questions. The results proved superior as measures of some forms of crop yield than the traditional non-probability methods of the big mail questionnaire, for example, that the Agriculture Department had used previously. It also provided the foundation for further developments of this area probability approach that were further developed in World War II, which we'll talk about later.